Nonlinear systems of equations. This will be assignment 30, and we're back to two variables now. So this would be familiar to us in terms of graphing. So we've got these two equations up here. You'll notice they're two variable equations again. And so, look, we can talk about graphing, and we'll do that very briefly. When you have two variables, it's a flat XY graph, Cartesian coordinate system. I'll point out y is to the first power and x is to the second power. Now you don't have to know the graphs that underlie these equations to do the question, but it helps. I would point out to you that that would be a parabola, and it opens downward because of the negative 5x squared, that sort of thing. All right, so that's a parabola. The other graph, it's not in standard form, but y is to the first power, x is to the second power. This one's also a parabola. The point is they're not lines. That's why it's called non-linear. These graphs have curvature to them. I hope you would agree that opens up the possibility of there being multiple points of intersection. For example, two parabolas could perhaps hit each other in two places. So when you put curvature into the question, not linear, non-linear, you have the possibility of multiple points of intersection. And we're going to talk about whether to use substitution or elimination. But as I just mentioned, there could be multiple points of intersection because these graphs have curvature to them. All right? There's a ton of different scenarios here. If you had two parabolas, it's very possible, for example, that if you were to put them on graph paper, perhaps the green one, the top equation graphs like this, and the other one graphs like this, and you'll notice in that picture I purposefully made them not cross at all. Wouldn't that be no solution? And I want to remind you that if you solve a system, and I'm making this up, but if you ended up with 0 equals 15, you would hopefully say, oh, there's no solution. And this picture here would explain, oh, the two graphs never touch each other. So that is, again, possible. And if that occurs, an equation like, for example, 0 equals 15, no solution, the graphs don't touch each other. All right? It is possible, I suppose, it is conceivable that if they're both parabolas, maybe they're the same parabola. Maybe there's one right on top of the other. And what would happen as we solve this that would tell us that? Oh, I suppose something like 0 equals 0. And wouldn't that mean, as we've seen before, isn't it conceivable? You'll see why I keep saying conceivable. Isn't it conceivable that there would be infinitely many solutions, right? So, and then of course you probably remember the other phrase the person used for infinitely many solutions. That's why I keep saying conceivable. Is it possible, is it conceivable that they would be the same graph? And that would be infinitely many solutions, right? Lots of babies, infinitely many. Again, I would prefer that you put infinitely. All right, so the point is, any of those three things could occur again, but I would say the major difference here is that because these graphs have curvature to them, there's the possibility of there being multiple points of intersection. Anyway, back to the methods that we could use here. I hope that when you saw this one, you said, y equals math expression. I can plug that math expression into that other equation. I can substitute it. So again, the substitution and the elimination would be the preferred ways of going after this, I would suggest to you. All right, so anyway, if we put that expression in for y down here, we will have 3x squared minus parentheses math expression, the expression that equals y. We're hopefully familiar and comfortable with the idea of substitution. If that's equal to y, we can put it in for y in the other equation. This now becomes a one variable equation. Therefore, it should be a flashback at this point, shouldn't it? Whoa. That's a quadratic equation, man. It's one variable, and it's got x squared in it. So you would go back to assignment 11. Oh my gosh, that's so long ago. Man, that was before spring break. That's when we were together in this room, wasn't it? All right, so all the things that we did on assignment 11 would now be applied to this new one variable equation. All right, let's see. Simplify. We'll distribute the negative into the parentheses, which becomes plus 5x squared plus 14x. Let's see. Oh, yeah. Combine like terms. Don't you miss that? Have you been practicing your Donald Duck? It'll improve your math skills. 8x squared plus 14x equals 15. You will notice that multiple terms have x, so we'll get it in standard form, which would prompt us to subtract over the 15. Let's pull this up here now, all right? So 8x squared plus 14x minus 15 equals 0, standard form. And then you hopefully remember from assignment 11 before spring break when we were all together in this lovely room. My agent's texting me again. We said you can either factor it or you can do the quadratic formula. And I think you all probably go, come on, man, please factor. I'm crossing my fingers. And so look, factoring is assignment 5. Okay, that was like, oh my gosh, that's like early February, I think. It might have even been January. So look, I don't have a lot of time to reinvent the wheel. I know it sounds snobbish, but it's just the way it is. I'm pretty sure, let's see, 2x times 4x makes 8x squared. You can write all the factors out. You know, I don't have time for all that reinvent the wheel factoring. Doodly-doo, doodly-doo. Assignment 5. All right. Let's see, I got 8x squared for first. We've got negative 15 for last. Let's confirm this. The outer would be negative 6x. The inner would be positive 20x. I hope you're not drinking or eating anything. Indeed, that makes plus 14x in the middle. All right, so as we practiced, there's tic-tac-toe. I don't care, factor it. Okay, so yes, that one factored. And therefore, we can now, by the way, I'm the only one in the building, so I can really scream now. Social distancing, I'm practicing it. I stay in my car the whole time here. I don't see another human being. There are people in the other half of the building. I come in a totally separate door, in case you're wondering about all that. And I hope you're taking care of yourselves here. Subtract that and divide, and this is negative 2.5. All right, so that's a value of x. And then, same thing, add the 3 over, 4x equals 3, divide by 4, divide by 4, 3/4 is 0.75, 2 different values of x. Now the error that we see frequently is for folks to put the two together and make them into an ordered pair, but those are both values of x. All right, and so in this little game we don't pair an x with another x. It's 2 points. There's one point with a value of x and a different point with another value of x. So, all right, and again, board space being at a premium, hit pause, catch up, do whatever you got to do, all right? Okay, so I'm going to erase this and pull it up here. I have to do this. You can always rewind. If I get going too fast, whatever, you can always hit rewind or pause. But the point is there's 2 different values of x, and we need to find the y value that goes with each of them. All right, and so I would suggest to you that, like we've been doing, once we begin discovering numbers, don't we substitute them back into one of these equations? And my thought would be, if you want to know what y equals, you'd use the one that says y equals. So I'm going to use this one, and again, space, we'll have y equals negative 5 times negative 2.5 parentheses squared minus 14 times negative 2.5. I'm sorry, I didn't plan ahead really well, but you get the point. We're putting this in here to get the point. All right, you get the point? Let's get a point. So, y equals, this is all arithmetic. I gotta be a total snob about that, and I know that that's maybe frustrating to some, but I gotta do it. So you square it and multiply and so on and do the order of operations. And so, you know, the further we get into the semester, and this is our last section, you know, crunching the numbers, I hope, is not a big deal. So if you do the order of operations to this, I'm going to write this down, and then I'm going to check it here to see if I did it right. 2.5 squared, negative 5, blah, 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 3.75. So, when x is negative 2.5, y is 3.75. And that would be one of these ordered pairs. It appears that that's the general picture. Two parabolas hitting each other in two different places, two different values of x, two different points. Same thing here. This x says, where's my y? And you go, okay, same thing. Let's go to the y equals equation again. And so, let's see. Let me get these out of the way. I could have done that earlier and had more space. Let's see. Negative 5 times 0.75 squared minus 14 times 0.75, right? Let's use the y equals equation because we want to know what y equals. And, okay, order of operations again. So, I believe if I did this correctly, I'm going to write this down and I'm going to look at my calculator again, so I reserve the right to change it if I want. Let's see, negative 5.75 squared minus 14.75, negative 13, you see it on the board. So, that would be 0.75x paired with negative 13.3125. And again, the idea would be that we got two ordered pairs for our answer because these graphs are curves, and curves can cross each other in more than one place, as exemplified by the picture that I had to erase. So, multiple points of intersection are possible when these things have curvature to them. Those two ordered pairs solve that system. Bang. All right, so the rest of these are going to follow the same theme. We're just going to practice probably 4 or 5 more of these. All right, let's do it.